Hi, so we're gonna talk about differential equation, and this topic is under separable variable. Whenever we have this kind of question, we will question ourselves whether this can be separated into dy and dx or not. So we will usually collect dy on the left hand side and dx on the right hand side. So I'm trying to collect them right now. What I'm gonna do here is I will move this term to the right, sorry. So I'll have negative x squared plus 1 over y dx, alright? But you have to check this negative sign is actually for the whole thing right here, alright? So you got to be careful for this. And then this y, we're going to move it back here, so you have to times y here, alright? And here you're going to divide x. So if you times y, you're going to have this one equals to negative x squared plus 1 over x dx. So when you have this kind, you can just integrate both of them. Alright? You can do side by side first in order to make yourself more clear. So for this case, you try to integrate this one in terms of y. First you think about is substitution. So if you let the power to be your u, you can't actually do this using substitution. So what you're gonna do here is you will try using by part. So according to LPAT, what you're gonna do here is you're gonna choose your u as the polynomial y here. So u is y, your du is dy. The dv, it's gonna be all this, so it's gonna be ey dy, v is just ey. Alright, so put it back here. You're gonna have uv, which is y ey, minus v du, ey dy. Alright, this is for the left hand side. I'm just gonna finish the left hand side first so that I don't confuse you. So this one's already done. Alright, so integrate ey, you're gonna get ey. Alright, so if you ask whether we need to put plus c or not, the plus c we will only put on the right, just once. Alright, so this part is done. So focus on the right hand side right now. This one, the negative sign, you can multiply in first. So what you're gonna have is negative x squared minus 1 over x dx. So you can separate them into negative x minus 1 over x dx. Alright, so you're gonna have negative x squared over 2 minus ln modulus of x plus c. As I said, we will only put plus c on the right. This is actually the general solution for the question, but since it's given the condition, you have to put it here to get the c. Students always confused when they have this kind of condition where they will put y as 1 and this is x, which is actually not the case. This is actually the x and this is the y. Alright, so x is 1, y is 0. So you're just going to show the substitution here. So 0, e0 minus e0. Okay, and then for this one, negative 1 over 2 minus ln 1 plus c. So this one is 0. This one, e to the power of 0 is 1. So we have negative 1 here. Negative half minus 0. Ln 1 is 0 plus c. So c is actually negative 1 plus 1 over 2, which is negative 1 over 2. Okay, so our final answer will be this one. I'm just going to copy back from here. Equals to negative x squared over 2 minus ln modulus x minus 1 over 2. And this is called the particular solution. Well, this one is the general solution. Okay. For the second question, we're gonna look at this example. So we're gonna try to separate them first. In this case, you're gonna see y is everywhere. So what I'm gonna do here is I'm gonna factorize out the y first. What you're gonna have here is negative y squared on the top is actually same as, so this one is actually e negative 2x times with e negative y squared. Therefore, you can add them up. So this term and this term has some common factor. So I'm just gonna take it out. So this one you're left with 1 plus e negative 2x. Okay, so the y here and the y here, these are of multiply relationship. So you can just bring it back there. So this one is actually e 1 over e to the power of y squared. And then 1 plus e negative 2x. So this one, when you multiply, you're going to have y e y squared dy dx. And then you still have the ex here, so you're just going to move it there. So it's just going to be ex at the bottom. 1 plus e negative 2x. So you have now collected all the y on the left and the x on the right. So I'm just going to move this there. dy equals to 1 over ex, 1 plus e negative 2x dx. Alright, just put the integral sign on both sides. So in this case, if you let the power to be the u, you can easily see that if you differentiate y squared, you're going to have 2y. So it will be easier for us to use substitution rather than by parts. So I'm just going to write down substitution. U equals to y squared. So your du over dy is going to be 2y. Remember, it's not dx because we are differentiating y. So your dy is going to be du over 2y. Okay. Draw a box to separate them. So put it back here. You're going to have y e to the power of u. And then your dy is going to be this one. Du over 2y. And then I'm just going to solve the left hand side first so that I don't confuse you. So if you see here, you can cancel out this one. Alright, rewrite them. You're going to have eu 1 over 2 du. Alright, I'm just going to integrate this. So it's going to be 1 over 2 eu. Substitute back, you're going to have 1 over 2e y squared. Alright, this is for the left hand side. So I'm just going to put the equal sign for everyone. Now let's check out the right hand side. So for this one, you can actually multiply them in first. So in this case, I'm going to change this into this form first. Alright, so when you multiply in, you're going to have e negative x. And e negative x times with e negative to the e to the power of negative 2x, you're going to have e negative 3x dx. Alright, so for this one, you can easily integrate them. It's going to be negative e negative x minus 1 over 3 e negative 3x plus c. As I say, we're going to put plus c on just the right hand side. You don't have to put on both sides. Alright, so since we have another extra line, I'm just going to copy this in. Like this. Okay, as you can see, we have the condition here. So this is just the general solution and not the particular solution, but we need to substitute this. So as I say, this is x, this is y. You can write it down to avoid confusion for yourself. Yeah. So put it in here, you show the substitution. E0, negative E0, 1 over 3 E0 plus C. So don't get too excited if you see 0 and you're going to put everything 0 because e to the power of 0 is 1. So 1 over 2 equals to negative 1 minus 1 over 3 plus C. Okay? So what you're going to have here is you're going to calculate this C. C is actually equals to 1 over 2 plus 4 over 3, which is 3 over 6 plus 8 over 6, 11 over 6. Alright, you don't just end here because you're going to write the final particular solution. So copy from here, 1 over 2 EY squared equals to negative E negative X minus 1 over 3 E negative 3X plus 11 over 6. That's your answer. Hi. So for the last example, I'm gonna do about trigo because this is one of the topics that students scared the most. It's actually not that scary. So I'm just gonna write this to make you see clearer. This negative sign means that it's 1 over. So what we're gonna do is we're gonna separate left is in terms of y and right hand side is in terms of x. So this one you're gonna multiply here, you're gonna get e to y dy equals to, this one is 1 over, what is here? Sine squared x sine 2x. So let me remind you that this is double angle and this is some identity. Does it seem familiar to you? I hope it is, because cos squared x plus sine squared x equals to 1. Alright, so this one you can change it into 1 over cos squared x, and this one is actually double angle. So what you have is sine 2x equals to 2 sine x cos x. Okay, so this one is 2 sine x cos x dx. So I'm just gonna put integral sign at both sides. Alright? Okay, so let's try this one first. So we can cancel out this one. What we're gonna have is integral of 2 sine x over cos x dx. Okay, so we're gonna use substitution. U equals to the denominator we will take as the u. So your du over dx is actually negative sine x. So change into dx, you have du over negative sine x. Okay, put it back here. You're gonna have integral of 2 sine x over u, and your dx is this one, du over negative sine x. I'm just going to draw a box here to separate them. Alright, so this one you can cancel out. You can have negative 2 over u du. Integrate it, you will have negative 2 ln modulus u plus c. We put a plus c on the right hand side. Don't forget that you haven't integrated this part. So when you integrate this, what you're going to do is you're just going to copy and divide by integrating the power, which is 2y. You get 2 times with ln base, ln e. So ln e is 1. So all this is going to bring down here, but we don't end here because this is only the general solution. We have the condition here, so we have to do particular solution. So the x is 0, y is 1. Sorry, y is 1. Put it back here. 1 over 2 e to the power of 2 times with 1, 2. So negative 2, I'm sorry, this is not the final answer, right? So your final answer is gonna be 2. I'm just going to rewrite this. Cos x plus c. So your general solution is here. Sorry for the mistake. Alright. So you're going to show the substitution. 1 over 2. You can write it here as well. So 1 over 2 e to the power of 2 times with 1 goes to negative 2 ln cos 0 plus c. Okay, cos 0 is 1. So negative 2 ln 1 plus c. Ln 1 is 0. So this whole thing goes to 0. C. So here you're going to have 1 over 2e squared. So your c is actually 1 over 2e squared. Okay. Writing your final answer. Copying from here. You're going to have 1 over 2e 2y equals to negative 2 ln cos x plus 1 over 2e squared. And this is your particular solution.